So hello everyone. In this lecture we are going to study uh, function in MATLAB. So function are basically M files that accepts input argument and return output argument after computing. The structure of the function subprogram is similar to any other program except for the function definition statement that should be included at the start of the function. The function subprogram include command and function and the function file is normally named after the function name. So we can write any function. So let's take an example and try to uh, make a function of this particular example. Let's take we want to calculate the root of a quadratic equation. Want to calculate roots. So we want to calculate roots of a quadratic equation. Let a quadratic equation be like ax square plus bx plus c, and we have to find the root of this particular equation after passing the value of a, b and c. Now we have to design a function in which we have to pass the value of a, b and c, and we will directly get the root of any particular value, the roots of the any particular quadratic equation. So let's try to make a program or a function. First open this script file, and now in the function subroutine you have to write first statement as a function, and then the output argument which will be outputted by this function. So the output argument are root r1 and r2. This should be equal to now let's take the function name. Now the structure of this function command is uh, you have to take function, then the output argument, then the name of the function, that is let's take roots 1, and then pass the input argument. The input arguments are a, b and c. Now you have to input the values of a, b and c. You have to pass the values of a, b and c to this function for getting the result in r1 and r2. So I will first uh, find a discriminant. Let's store discriminant d is equal to that is b square minus 4ac. You have a formula called a formula for finding the roots of any quadratic equation. You have d is discriminant which is equal to b square minus 4ac, which is now we can calculate the value of discriminant, which is b into b minus 4 into a into c. This is discriminant d, and now we can find its square root as well. So we stored this in d1 equal to square root. We have used another function, that is square root, sqrt, square root of d. Now this discriminant is completed. Now the roots can be defined as r1 will be defined as minus b plus d1 divided by, now put this in bracket, and complete divided by 2 into a. Similarly, root r2 can be given as minus b minus d1 divided by 2 into a. So this completes the function, and you can save the function in the name of its function name. That is, we have taken root 1. So function will be saved in the form of that particular root 1 name. So you have to directly click save, and here function root 1 is stored. As you can see, that m file have written fx, that is function, over here. So you can call this function simply by writing its name root 1 and passing all the parameters, that is a, b and c. Let's take the value of a as 1, 4 and 4. When you hit enter, sorry, there is an error. We have to put comma after each value. Now when you hit enter, there is some error over here. So there is an error. We have not put s over here. We have taken the function name roots1. So here we take only root. So try to change. Here we will put s and then enter. There are two roots which are r1 is minus 2 and r2 is also minus 2. You can check for any other value of a, b and c. Let's pass 1, 7, 9. When you hit enter, so we forgot to apply commas after each value. So let's hit enter. These are the roots, that is minus 1.6972 and minus 5.3028. Let's try to check for any other value of a, b and c. Let's pass this function roots1. Let's pass the value 279. Oh, sorry, we have not put it comma after each value. These are the complex poles or complex root for this particular equation. So this is the program for roots. Now let's try to code some other programs. Now these are some of the functions which can be used or which are used in optimization problems. So here there are so many functions over there. First one is Rastrigen function, which is this formula which is used, and for Achille function, this type of formula is used, and so on. There are so many functions is there for optimization problem. So let's try to code one of the function. Let's take this BLA function, which is, I think, this equation. This equation is for BLA function, and we try to code this BLA function, which is this one. So let's open a new script. Let's try to code this. Let function is the starting, and function we will store this value in f equal to, and the name of the function is BLA. So write BLE and passing the parameters. I think we have two values, two parameters, that is x and y. So we can write over here x and y. And let's try to code. Simply you can write f equal to so function f is equal to 1.5 minus x plus x into y to the power of 2 complete power 2 plus 2.25 minus x. Here you take bracket first, and plus x into y into y, close the bracket, to the whole power 2 plus 2.625, consider bracket first, 2.625 minus x plus x into y to the power 3, bracket close, to the whole power 2. Now this forms the function, or you can make here one bracket for y cube. Now this forms the function, and you have to save first before execution. So the name is itself showing BLA. You have to simply click save. Now uh, let's take the value of x equal to 0 and y equal to -1, and sorry, x equal to 3 and y equal to 0.5. This will give the function value as 0. So passing BLA with input arguments 3 comma 0.5. When you hit enter, this will give you the function value 0, same as written over here. So let's try to check the value for some other value. So pass it BLA with some other value. Let's take 3 comma 7. When you pass it, the answer is 1.0798 into 10 raised to the power 6. Here 10 is represented by E in MATLAB. So this can be read as 1.0798 into 10 raised to the power 6. Now let's try to code some other function. Since these functions are required in the optimization problem, so I will try to code minimum of 3 functions so that we can use it in optimization as well, these functions. So let's code this AKLA function. So first you have to write function, then the value of j or function f equal to The name of the function, I think this is Akele. Let's check out the spelling first. Akele, and we have two function parameter, that is x and y, which we have to pass, and function f is defined as minus 20 exponential exp minus 0.2 multiplied with square root sqrt. This is another function. You can call any function within a function. So here in this function akele, we call square root function as well as exponential function. Square root of 0.5 x square multiplied with x square plus y square. So x into x into x plus y into y. This completes the first part. Now next is e exponential 0.5 and multiplied with cos 2 pi. In the cos function you have to write 2 into pi. For pi we have to use pi into x plus not plus over here, we have to complete this loop and then put plus sign cos 2 into pi into y. I think this complete the function. Second term plus exponential e to the power exp1, you can pass simply exp value of e plus 20. This completes the function. You can save it as a akele function. You can pass the value x equal to 0 and y equal to 0. This will give return the akele, passing the value 0 comma 0. I think there is some error. exp, here we have not put a multiplied sign, so MATLAB will not understand what is meant by 20 into 20 exp. So I have to save the function again and try to evaluate, and you can see the function value is 0. So now you can evaluate this function for any other value as well. Okay, passing the value 2 comma 3, and this will give you the result 7.9889. I hope this Akele function is clear to you. Now let's try to code another function, which is Let's take any another example. BLA we have already code. Now let's try to code this buckin function. So spelling of the buckin is bukin. So let's make a script file and type function with the value of the output argument as f equal to function name is buckin. I think the spelling is bukin. That is buckin function, buckin, and passing the input argument as x comma y. Now you can simply write the equation of this function f equal to 100 multiplied with sqrt square root and passing this square root with absolute of abs. For absolute you have to use abs function y minus 0.0001 multiplied with x multiplied with x. So this will give you the first term plus 0.01 multiplied with absolute of x plus 10. So I think this completes the coding of this function. And let's try to save this. For saving, you have to click on save. The name is buckin is itself written over there, so you have to simply click save, and buckin is stored in the form of function here. This is the buckin file in the current folder. Now we want to evaluate this buckin function for x equal to minus 10 and y equal to 1. Let's try to find buckin 10. The value of y is minus 10 and 1, minus 10. When you hit enter, you will see that the value is 0. I hope these three functions are clear, and let's try to find its value, this function value, for any particular value, for any other particular value of x and y. Let's take 1 comma 3. When you hit enter, the value is 173.0262. So next is function handle. Function handle stores all the information about the function which is needed for its execution later on. So agar we have to use any function for its execution in the later part of the program, we have to use the function handle. A function handle can be created by applying @ operator before the function name. So function handle can be created. Let's try to create the function handle for this buckin function. Or let's try to code one another function that is Let's take an example of another function. Now, let's take name function, name of the function with value f equal to func function of time. Name of the function we take here is func. So f can be given as 4 into exponential of minus 2t minus 2 into t. You can simply write and here, or it's your choice. You have to write and or not. It doesn't matter. So when you save it, this will save as function. So we have saved this function as a function. It is here in the current folder. So when you create a function handle, so you have to write handle and pass this handle with a function at the rate the function name at the rate function name is func, and when you enter it, this will store function for later use in handle, and you can pass directly handle and vary the value of t and from 0 to 5, and when you click enter, this will give you the value of 6 value of function for each value of time. So when you click enter, this will give you uh, 4 for 0 and 1 and 0.5413 for 1 for time equal to 1, and so on. You can change also handle, and you can pass the value 0 to 0.1 till 2, and when you hit enter, this will store so many particular values as per the increments. I hope this function and function handle is clear to you. Function handle is a very good property and it is used for optimization of a particular function. So I hope all these uh, properties and uses of function are clear to you all. So thank you very much.